The smt-gui is a graphical workspace or a sandbox which provides a convenient common environment to develop advanced features and analysis capabilities. This demo video will expose you to some of the things it can do. The smt-gui is invoked like any other SMT command. It can be connected to a live data feed, the OMS, or to an OMS history file, which was previously obtained via the smt record command. Right now, once invoked, the splash screen appears. You can see that it's reading the OMS history file. It takes a while to process this data. Depends on how big the cluster is and how many hours the data was collected. And then it goes off and starts building some internal data structures. And once it's finished, the application appears. This is the initial set of windows you'll see when you start up the program. It's divided into three main sections. This left section is the fabric navigation area, and it shows the fabric represented as a tree. At the bottom here is an event and messaging area, which is where you would go to see what the program is actively doing at any time. So it's more of a diagnostic area. And the large area in the center here is the main working area where the results of queries or other information you might ask for is displayed. There's also a toolbar area up top, and then at the very bottom is a set of playback controls, and I'll talk about that more later. I should note that the GUI is a work in progress, and that although it's incomplete, there's still many useful it has many useful capabilities in its current form, so it's being made available, but you should just understand that it's constantly being updated, and so what you see here in this video is probably a more advanced version is probably already available. The purpose of this video is to expose you to different aspects of the GUI and its logic. I'm not going to dwell on any particular topic or area of the program, so you can always explore the GUI on your own. This demo uses an OMS history file which was obtained over a 4-hour period from the CAB cluster and fabric. And the overview here, fabric overview, displays the composition of CAB. It has over 1,450 nodes, most of which are leaf or compute nodes. It also has almost 7,800 ports, most of which are switch ports. In the right-hand corner, there's a couple of timestamps. One shows that OpenSM has been running for almost over six weeks, and then there's a timestamp which shows the OMS snapshot that we're currently looking at, which was taken at 8:10 in the morning on March 21st. Let me take a minute to talk about timestamps. The OMS history file we're using for this demo consists of 80 OMS timestamps, snapshots. Each snapshot has a unique timestamp, and ideally they are equally spaced in time, different by the performance manager's sweep interval. The current timestamp up here is displayed in red simply because it thinks the timestamp is stale, and stale is defined by older than 2 performance manager sweep intervals. And since we are using an OMS history file, all of the data is older than 6 minutes. So when you're playing back an OMS history file, this timestamp will always be red. If this were connected to a live OMS feed, you'd expect the timestamp to remain black, indicating it's being constantly refreshed. Timestamps show up in a variety of places throughout the GUI. For example, here and here in the playback controls. In the playback controls, this shows that this is the current snapshot that is being displayed, and this second value shows the end snapshot time, which shows up over here. If we click play, the system will step through the time stamps or snapshots, which we have a collection of 80. And as the time increments, we see it increment here. We also see it increment here. And it in fact is incrementing throughout the system. Let's stop it. Now, although the connection topology of every fabric might differ, there's usually enough hierarchy so that they can be represented in a tree form. And that's what's happening in this area. The top level or root node is usually an artificial node and is just the name of the fabric. And the remainder of what's displayed here are the top level switches. Now each of these can be opened, and what they are connected to will be displayed here, and in turn you can open those and continue on until you reach the leaf nodes or the compute nodes. Each of these nodes in turn can be selected, and their attributes and values can be displayed. And for example, a core switch might have 36 links. Each of these can be selected, and each of these can be opened. Attributes and values can be displayed, all corresponding to a single snapshot or timestamp. And if we start the play process again, you will see certain values will remain the same, but the dynamic values, such as transmit data in this particular port, will change as the timestamp updates, assuming of course that there's any traffic on this particular node. Although it's convenient to represent the fabric in tree form, it's really not very accurate to display and expose the topology. To do that, you really should display it in graphical form. And by clicking on this option, two things happen. First, the graph starts to plot, and what's happening now is it's trying to organize it into a visually pleasing way using a specific layout algorithm. And that shows up in this panel down here. This window shows up, and it has graph-specific controls. And here is the layout option for the default layout option. Several things. There are also graph controls for zooming and picking and collapsing. This is an active graph. Once it settles out here, you can isolate certain entities in the graph. If you're interested in looking at certain things in more detail, you can isolate them and zoom in on them. And this just allows you to focus on a smaller subset or group of the fabric. These are also active controls. If you click on one of these nodes, this is a leaf node, you can see its attributes and values. Same for switch nodes. These are colored. The decorations here represent different levels of the fabric. So this would be the first level. This would be the next level up. It shows that it's a switch with 36 links. With only a few exceptions, all of the information displayed in the main areas of the GUI correspond to or are derived from one or two OMS snapshots. The play controls down in the bottom section can be used to move through the snapshots. You can set the playback speed. The default is 20. You can tell it to wrap when it's reached the end, and you can start and stop it. You can also use the arrow keys to single step through the play controls. Whoops. Like so. And you can also just simply grab it and drag it. As the flight recorder data is played back, traffic and error analysis is performed using successive OMS snapshots. As dynamic errors occur, various GUI components are decorated. Here we can see two nodes have turned red. We can drill down to see what has happened. Further, we see port 9. There's something going on with port 9. We can look deep and see VL15 dropped. If we are interested, we can click and do some advanced analysis. This popped up in a different area. Let me drag it over. This is what you get. And we can see the counts. This graph shows counts for this counter. This is absolute raw counts. This is the black line. And this, now we are showing for the entire 4-hour period. The black line continuously goes up. That shows that we are continuously getting VL15 drops on this particular port 9 of IB18. The count seems like it ranges between 0 and 3, the delta, for every 3 minutes. It seems to be constantly incrementing. That's what the red shows. It's going between 0 and 3 each time. I selected the advanced to show, compare it against receive and transmit data to see if there might be any kind of correlation between the actual traffic. That's the purple and magenta here. It's difficult to see any kind of correlation. It looks like just a constant run. If we want to focus in on any particular area, we can drag this slider and center over a peak perhaps in time, and the table down here shows the values, the actual values, the timestamp values, the actual values, and the units of what is being displayed up here. Sometimes you may just want to monitor the fabric over the course of time as data comes in. Make sure it's either hooked up to the service or is playing, like this is. There are several ways to look at the traffic or errors as they happen. One is to just check the fabric utilization. This is looking at all the links in the system and trying to determine how many have traffic flowing over them and how much. And you can see that most of the links, 99% of them, are using very little bit of their bandwidth. You can also look at the top traffic nodes. You can look at top error ports, for example. You can go to, let's get a top node and drill into it and check its utilization. This is a leaf node, so there's only one. Let me get a switch. And look at its utilization. So all of the ports are displayed here. The errors, it looks like Most of the errors that are happening at this instant in time on the fabric are symbol errors. This looks curious. They're all port 11, so these are probably downed nodes, down ports. This one looks like the same one we saw before. The symbol, the VL15 drop errors on port 9. Yes. Yep, that's the same one. If you're interested in looking at ports that might have a lot of traffic, they can be identified in a variety of ways. One is through the utilization screen. One is through the top traffic screen. Here we can see port 20 on this particular node is using about 20 or 4% of its bandwidth. That's not a lot, but it may be one of the highest. We go back to port node IB42. We can see that it has been decorated with a blue little node attribute, which means high traffic, and sure enough there's port 20. It's blue. We can look into port 20. Again, blue on the counter attributes. We blow that up and there's a blue flag. It looks like for both the transmit and receive, they are among the busiest. We can look at one of their counter values in graphical form, and indeed we see that, let me make it bigger, that for a period of the time it was rather bursty. This graph shows the counter values in raw form in black. We see it increment radically here. Blue shows the delta in change over period counts. So it was relatively quiescent and then big change for a moment of time. The light green, it looks to be hidden under the blue, but it is in megabytes per second. And then the magenta color is a percentage of the maximum throughput for that port, and so we see that it is down in the 5 to 10% range, maxing out around whatever that value is. If you want to know exactly, again, drag the slider, and we see that it's maxing out at about 8% of its theoretical bandwidth. So that's one way to look for traffic. I think we've touched on the main features of the GUI. There are each topic you can dig into deeper on your own, of course. There might be a few extras here, like for example, you can look at the details of the fabric, which if you click on this, you can look at the various attributes and the values of the configuration file. This is OpenSM configuration. You can look at the MAD counters and display, if you want to. I don't see any obvious errors here, but if you wanted to look at a graph of the values of MAD sent or received, you can and have the same sorts of controls. Oh, one kind of fun thing you can do is discover which clusters might have an OMS service running. You have to, of course, set up tunnels prior to launching this. So I have a variety of clusters I monitor, and I keep tunnels to the service open. And so this is going out to discover which ones might still be running and which ones are open. There we go. So there's 1, 2, 3, 4, 5, 6 different clusters, and they range in size from Looks like 179 nodes at the smallest, all the way up to cab, which is the biggest, 1459. One interesting fact is I noticed that most of these were started in March, but a couple of these have been running since November. So that's kind of nice to know that they've been up and running the entire time, and they're still responding. So that's all for this video. In the future, I may create shorter what's new type videos when I update or provide a new release of the GUI.